Hi everyone, welcome to section 4.8. We are going to divide this section into two parts. So we're going to deal with the first half today, 4.8a, because we are learning about a brand new kind of number. Believe it or not, they're called complex numbers. Complex numbers sometimes are called imaginary numbers, and that's unfortunate because they're really not imaginary. They are genuine numbers, but they're not part of the real number system. They're a separate system, but they do exist in real life. And so we need to be able to represent them in math, and we call them imaginary. In fact, a symbol for them is a lowercase I. This is how I write the imaginary unit, and the imaginary unit has a value in math, and the I is equal to the square root of -1. I is the square root of -1. Now, we have just been working with the quadratic formula, and we said if we end up with a square root that's negative, then that means there's no solution because you can't have a square root of a negative number. Well, there are square roots of negative numbers. You just haven't learned them yet. They're what we call imaginary numbers. They aren't real solutions. They are complex solutions, and so, but they do exist. In fact, electricians work with these all the time in what they do, so they are real. So if there was some kind of number that when you multiplied it by itself, you would get -1, that number would be I. So I is equal to the square root of -1. Now think about that. That means that I squared is the square root of -1 times the square root of -1. Well, what's the square root of -1 times the square root of -1? Hopefully you will say -1, right? I squared is -1. So let's take it a step further. What would I to the third power be? That's I squared times the square root of -1, right? So that's negative square root of -1. Kind of crazy, but that's what it would be. What would I to the fourth degree be? That's sort of like I squared times I squared, isn't it? I squared is -1. So what's -1 times -1? +1. So when we get up to the fourth degree, we've multiplied I by itself 4 times, we finally get to 1. You aren't going to be doing that. I just wanted to show you. Basically, you're going to be dealing with I, and you are going to be dealing with I squared. So please remember that I squared is -1, and that I is the square root of -1. So let's see how this works and what we mean when we say complex numbers. All right, the first example in your book is what do we do? How do we simplify the square root of -18? So first we want to find out, are there any perfect square factors of 18? And there are. 18 is 9 times 2. So what I'm going to show you all 3 factors in this. So we have a negative, we have 9, and we have times, and we have 2. 9 times 2 and then -1 because it's -18. So if I bring this -1 out, it becomes I. And the square root of 9 is 3. So I bring this out here, and it becomes 3 times I, and inside my radical is left the 2, and I've simplified negative square root of 18. Let me show you something simpler, because they start off with something a little complicated. Let me show you. What's the square root of -5? Well, if you bring that negative out, it becomes an I. It's I square root of 5, all right? Or the square root of 5 times I is the square root of -5. That's what you do with negatives. You bring them out and they become our I unit or imaginary unit. Another one, square root of -12. 12 is 4 times 3, right? So we have 4 times 3 and we have a negative. That becomes an I, so bring this out. That becomes 2 and an I, and the 3 is left inside the radical. I hope you're good at simplifying square roots, because we're going to practice this. Finding perfect squares and pull out their roots out in front like that. So square root of negative 12 becomes 2i square root of 3. Square root of negative 25. What do you think that is? Bring the negative out, and what's the square root of 25? It's 5, right? So this is just 5i. Don't forget the I. Please make sure that I can tell it's an I when you write this by hand. That's why I put the little hook at the bottom so you know it's an I. All right, complex or imaginary numbers have this form, and this is the form you want. A plus bi. This is the real number part, plus, and then this is the imaginary part. And this is the way you want to show them. So for instance, if I don't have any imaginary part at all, this is 0, then I just have a real number. If I don't have a real number attached, that's a 0, then it's pure imaginary. But often they will be complex like this. For instance, 7 plus 3i. All right, here's the real part, and then 3i is the imaginary part. Or it could be minus. 5 minus 17i. There we go. So there's the real part, there's the imaginary part. You always write real plus the imaginary. It's always in that order, that standard form. I want you to write your answers in standard form. Believe it or not, we can graph complex numbers on a complex plane. Not a regular coordinate plane, but a complex plane. In a complex plane, the x-axis is the real axis. So the real portion of our complex number is referenced on the x-axis. The y-axis becomes the imaginary axis. And so the imaginary portion of our complex number gets graphed in reference to the y-axis. So in other words, if I have, I'll make one up, 2 plus 3i. If I want to graph the number 2 plus 3i. My real portion is positive 2. My imaginary is positive 3. So it would go the same place that the ordered pair 2, 3 goes. Just like that. Okay, you're also going to be asked the absolute value of a complex number. Remember, absolute value is always distance from 0. So if I want to take this number and find its absolute value, I need to find its distance from 0. I need that distance right there. So we are going to use our distance formula to do that. Remember, the difference between 0, 0 and here, this distance is always my x. This distance is always my y. So it really is, the absolute value is the square root of a squared plus b squared. That's how you do it. So in this case, it's 2 squared plus 3 squared, or the square root of 4 plus 9, or the square root of 13. That is the absolute value of this number. Okay, so if I ask you what is the graph and what is the absolute value of this complex number, then remember this is your x, this is your y. So when you graph it, you go to the left 5 and up 3. It's negative 5 is the real part, positive 3 is the imaginary part. I've just graphed it. Okay, now I want the absolute value. How far is this from 0? What's this distance? So I'm going to take the square root of 5 squared. Actually, it's negative 5 squared, but it's still going to be positive, so it doesn't matter. 5 squared plus 3 squared. And this is 25 plus 9, or the square root of 34. The absolute value of this number is the square root of 34. This is pretty simple, and so students get it. They practice it a few times, and then they forget. And they come to a quiz or test, and these problems invariably get missed. So have this in your notes or get it in your head so when you see it on a quiz or test, you'll remember, oh yeah, I remember. This is how to graph a complex number. This is how to find its absolute value. Let's do 2 more just for good measure. I have this number 5 minus I. Graph it, find its absolute value. So when I graph it, I go, the real portion is 5, the y portion is negative 1. I've just graphed it. That's the graph on a complex plane of 5 minus I. What's its absolute value? It's the square root of 5 squared plus 1 squared, or the square root of 26. This one is 1 plus 4i, so the real portion is 1, that's the x. The y portion is 4. There's where it gets graphed, right there on the complex number plane, the complex plane. What's its absolute value? The square root of 1 squared plus 4 squared, or square root of 17. That's its absolute value. Okay. Hopefully that helped. Now you can add or subtract complex numbers with each other. It's really not that hard. You just combine like terms in a way. So in this case, I have 4 minus 3i, and I want to add to it negative 4 plus 3i. So I just do it's like combining like terms. So I have the positive 4 plus a negative 4. Well, that's 0. Okay, 0. Okay, and then plus negative 3i plus 3i. Oh, good grief, that's 0 too. So this one, when I add those together, that one is 0. Because these are opposites. Let's do another one. All right, in this one we're subtracting. Be careful of the signs. They'll get you if you're not watching. So we're going to do the same thing, only subtract. So the real and the imaginary part. So 5 minus a negative 2. Careful, we're subtracting a negative. So that would be 5 plus 2, or 7. And then we do the negative part. Negative 3i minus 4i. So negative 3i and minus 4i is negative 7i, and I have just subtracted one from the other. Do you see how this works? Here's one for you to pause and practice. I want to make sure that you've got this down. So we're going to take 7 minus 2i plus negative 3 plus I. I want you to add those together. So pause, write it down, then restart the video and see if you got it right. Okay, you should have gotten 7 and negative 3 is 4, and negative 2i plus positive I is just negative 1i, so it becomes 4 minus I. How did you do? Let's try another one. Here's another one to practice the same way involving subtraction. So go ahead and pause the video again and solve 1 plus 5i minus 3 minus 2i, and then come back and see how you did. Okay, you should have gotten 1 minus 3, which is negative 2, and 5i minus a negative 2i, it means positive 2i, so plus 7i. Did you get subtracting the negative? So negative 2 plus 7i. And don't go 7i minus 2. Remember, in standard form, it's real number followed by imaginary. Not only can we add and subtract imaginary or complex numbers, we can also multiply. So I have this imaginary number 3i, and I'm going to multiply this complex number, negative 5 plus 2i, times that, and you're just going to apply everything that you've learned in the past. You're going to do the exact same thing. This is the distributive property. So first you would multiply 3i times negative 5, and that's negative 15i. Then you're going to multiply 3i times 2i. Number times number, I times I. 3 times 2, it's positive, 6i squared. Now, how do we simplify this? Let's go back to what I did at the beginning of this lesson, and let me remind you, what does that I squared mean? The square root of negative 1 times the square root of negative 1 is negative 1. So this is the same as 6 times negative 1. What that effectively does is change this sign. So this is 6 times negative 1, or negative 6. So now I have 15i and negative 6, but it's not in standard form. Real number followed by imaginary, so I'm going to rearrange it. Negative 6 minus 15i. This is just what it looks like. You have a complex number times a complex number, and you need to multiply. So what you are going to do is FOIL. You're going to FOIL, and it's not as bad as it looks. So let's just walk through. You guys know how to FOIL. You're going to do the same thing with imaginary. So first you're going to multiply 4 times negative 1, that's negative 4. Then 4 times negative 2i, that's negative 8i. Okay, now we're going to multiply 3i times negative 1, that's negative 3i. And 3i times negative 2i is negative 6i squared. And now we're going to simplify. This is negative 4. Combine like terms, negative 11i. And this becomes, this I squared is negative 1, and negative times a negative, this becomes positive 6. So now I'm going to combine negative 4 and 6, and I get 2 minus 11i, and there's my final answer. Your turn. 7i times 3i. What do you get when you multiply that? Pause if you need to. Come back and see if you got it right. Okay, you should have gotten 21i squared. I squared is the same as negative 1, so this becomes negative 21. Your i's disappear, and that becomes the real number, negative 21. This one you can't do in your head. Take a piece of paper, take the time, please, please practice this. Please foil it. See if you get the right answer. Come back and I'll walk through it and we'll see how you did. Okay, so when you foiled it, you should have gotten 8 plus 10i minus 12i minus 15i squared. So that becomes 8 minus 2i. This becomes plus 15. So that becomes 23 minus 2i. And there's my final answer. How did you do? We are going to stop this lesson there. It's been long enough already. And we are going to talk about more use in complex numbers. Believe it or not, it gets worse than this. But we've covered a lot. So hopefully practice this, work with them, get to feel comfortable, especially this whole I squared concept. It just changes the sign. It's pretty cool once you see how it works. And then next time we'll even do more and show how it works in equations and how do we deal with, now we can go back to quadratics. How do we find solutions when you have a negative square root, all that kind of stuff. So we will do that next time. But that's it for now. This is more than enough. So I'll see you then. Bye for now.